How many of you are junior developers? All right, so only 2 people are really going to learn something. I want to be honest with you all. This talk is geared for beginners, and this is mainly because about 12 years ago, I was sitting in your spot there. People were talking about a lot of stuff. I didn't really understand what was going on. So because there are only 2 beginners here, relatively, and I'm considering beginners under 3 years, I'm going to rely on all of you senior developers who know everything to help guide this along. So I'm going to be asking you questions about your experiences with certain architectures. And I want you to be honest, like admit to some of the mistakes, admit to some of the failures, and just kind of like help all of the newer people kind of like feel welcome to this industry because we need it. At the end of the day, you're going to be the one dealing with all the problems that they create. So just keep that in mind. All right, so my talk is about keeping the HTTP framework out of your app. I will be honest, this talk has little to do with HTTP or the web. It's really an architecture talk. I just wanted to kind of, clickbait you all into coming here. So apologies in advance, I've lied to you, but hopefully you can trust me when I talk about some of these other things moving forward. I'll go ahead and talk a little bit about myself. I'm William. I have over 10 years of experience as a software engineer, and I'm a former OSS maintainer. The product that I built was GitHub Desktop, and that's kind of what kind of got me really interested in making sure that I can cater to the younger generation, right? Like making sure that software is accessible for people who aren't experts. Because let's face it, most of us are not experts. I'm a fake photographer. Here's some of the photographs that I've taken. That's me traveling for food. That's one of my favorite things to do, is to eat. And the only thing that I travel for is for food. I really don't care about attractions or any of that other kind of crap. It's just the food. I'm a gentleman racer. I race my car, my karts, and I also have a race bike that I put on the track every now and again. Although now that I'm over 30, I rarely ride my motorcycle. Something in me is just, I don't know, I have a lot of fear about it now. I'm just like, oh, what if I fall? Then I gotta like try to type with messed up hands, and it's too hard. I'm roommates with a dog. There's my little dog right there. His name's Roscoe. He keeps me a lot of company. I haven't seen him in a while because I'm here. So I hope that you all actually participate and make it worth it. It took me about 8 hours to get here. And now that we're in person, let's pretend that we're actually in person. Otherwise, I could have just did this over Zoom. So hopefully you all will participate and make this worth my journey. This is my niece. I don't really talk about it much, but this is my niece. I'm trying to turn her into a gentleman, well, I guess a gentlewoman racer. I don't know. She's really into cars now, thanks to me. So hopefully I'll get her a kart when she's old enough, and we'll put her on the track as well and see how she likes it. Finally, I'm a developer advocate for OneSignal. I'm gonna get into what OneSignal does right now. We send over 10 billion messages a day. We own a significant market share of all of push. As you see, 68% of the web push market share, 64% of mobile push, and we're installed on over 1 billion devices. So we support over 30 platform integrations, and you can look us up on onesignal.com if you're willing to learn more. And I'll move on to a little bit about yourself. So I'm gonna ask you to participate, and more than just raising your hands. This is the last talk before the keynote. I'm tired. I imagine that you're all tired, so I'm going to ask you all to do some things that you may not be comfortable with doing, like standing up and maybe looking and saying things with your mouth. So let's go for it. So how many of you all have at least 3 to 9 years of experience, software engineer? Stand up if you do. All right, so for all of you who are sitting down, you either have more than 10 years of experience or you have fewer than what they have. These are your mentors. Find them after this talk and ask them how they got to where they are. Put you all on the spot. All right, how many of you are what you would consider intimately familiar with design patterns? Raise your hands. Intimately familiar. I see one person in the back. What is this? What's this? Like, just a little bit. I just know, back in the day, I knew a little bit. All right. Well, unfortunately, there's not a lot of people who know. I was hoping there would be more, so I guess some of you may learn something, but we'll see. Probably not. We'll see. All right, how many of you are familiar with architectural patterns? With your words. Say, I am. No one. Okay. All right. All right. All right. Maybe I've underestimated them. All right. How many of you have ever had to migrate from a database in your app? Like from one database like SQL Server to Postgres or MySQL to some other cloud native database platform. How many of you have had to do that? All right. Everyone who raised their hands, did you like it?
No.
No? You're laughing. What didn't you like about it?
Relational documentaries.
Did you have to change your app code at all? How do you feel about having to change your app code because of a database? Not great. It's not. That's actually what this talk is about. So even though I presented it as web and all that kind of crap, it's not really about web. It's about making sure that your dependencies, implementation details, don't leak into your application code. So that way, if something does have to change, you don't have to go and change your application code, right? So wouldn't it be nice if you can say, hey, you know what? I'm tired of Postgres. I want to switch to something else. I'm gonna just switch to something else and I don't have to worry about my application. Wouldn't that be nice? It's actually the whole point of this talk. And we'll kind of get there. It's actually a very, very, very simple concept. It's so simple, in fact, that my demo was originally, I was just like, man, this is too simple. So I had to go and make it a little bit more challenging and more difficult so I can like make it seem like it's actually a lot of effort, but in reality, it's very simple. All right, so let's go on. Oh, sorry, this is a little weird for me. It's not showing me the same thing. All right, so what's the problem? Let's assume that you start off with a basic web API. It does one thing. It fetches some data from some web resource or from API. Well, if you're anything like the kind of apps that I've worked on, they're gonna change over time, slowly. You're gonna add more functionality. You're probably gonna integrate with a lot of third-party APIs. You're probably gonna start integrating with a database. You're probably gonna have some cross-cutting concerns that are gonna start going into your app code. Well, the problem is sometimes the things that you choose at the beginning of your project are not the things that you're going to use toward the end of your project. For certain reasons, things like technical limitations. A good example that I've recently faced, which is why my title is actually web, is that I started my project off with an Express app. I now have to change it to something else. And fortunately, I designed myself in such a way to where it was pretty simple to just change to something else. And I was like, oh, maybe I should share this with other people because I've faced this problem in the past, about 8 years ago, and about 9 years ago, about 10 years ago. Basically, what I'm trying to get at is I faced this problem consistently until I really put a lot of effort into like not dealing with this problem again. All right, so why do we have this kind of problem? Well, it deals with something called coupling. Who here knows what coupling is? Tight coupling, loose coupling. You there?
Yeah.
Yes, you. Tell me what tight coupling is.
Tight coupling means that you have potentially two systems that are, if you make changes in one, you absolutely will not put changes in the other, either because of inappropriate knowledge and dependencies, or just because one of them expects the other to do things a certain way.
Yes. How many of you all have experienced the problem of tight coupling, where you change one thing and all of a sudden you have to go change this other thing, and because you change this other thing, now you have to go and change this other thing, and because you change this other thing, you have to go back over to this other thing and change that. How many of you have experienced that? Is it pleasant? You like it? Did it make you want to quit your job? No? All right. Well, we're going to be talking about how we can not build tightly coupled systems. That's really the point of this talk. All right, so before I move on, I do also want to add in that your implementation details, and this is, I'm going to get into what those are. You don't want to be constrained by those, right? Like you don't want to be limited by those types of things, because at the end of the day, you're building an application that people are going to use, right? Like chances are you don't want to have to change the thing that your people are using because the database doesn't support something that you expect, right? Like that doesn't make a lot of sense. Maybe it does to you, it doesn't to me. Hopefully after this you'll agree with me. All right, so here is a graph of software complexity. What I want you to take note of is that it's not linear. How many of you know what this function is called? If I were to ask you like in big O notation, what would this be called?
Exponential.
You can call it that, yeah. Someone else?
Logarithmic.
Who?
Logarithmic.
It could be a small n squared.
I would call it quadratic. Yeah, no, I wouldn't call it logarithmic. I would call it quadratic or just nonlinear. The point is that software complexity is going to grow and compound over time. The more stuff that you add, the more dependencies that you add, it is necessarily going to become much more complex than you expect it to become. And this is just something that's fundamental in software. It's hard to get around, right? So it's like, because it's so difficult to get around, we have to put a lot of effort into making sure that we can make sure that this grows as slowly as possible. Some of the other reasons why software is really complex is because you don't always have control over the systems that you integrate with, right? Like I imagine that none of you have built Postgres or Stripe or Vercel or any other tools that we use in our software. So imagine one of your vendors, they release a new update and it breaks something. You don't have any control of that. You can't say, hey, you know what? Wait on that push right there. If my customers, they're using my product over here and it's going to break their system if you do this. Chances are that's not going to happen. So we have to account for that, which adds complexity into our system. So we want to be able to figure out ways to shield ourselves from those types of changes. And the reason why those other systems are changing is because there's constant pressure, right? Like we're not the only user, right? So let's say that I use GitHub. Well, I imagine that there are probably 20 million other people who also use GitHub. They're not going to be that responsive to what I want, right? It's a lot of people asking for changes, and because of that, GitHub is necessarily going to change. So if I have a strong dependency on GitHub, well then I need to make sure that I do my part to make sure that those changes don't affect me that much. Sometimes we do a really good job of that, but in a lot of the software projects that I've worked on, we don't really do a great job of that. I imagine that, at least for the newer folks, you probably saw a real software project and you're like, what the fuck? How does this even work? Like, it's amazing that things work. That was my experience, at least, when I first started. I was just like, oh my gosh. Anyways. One of the other reasons why software is complex is because programming is hard. I know that nowadays we like to say, oh, programming is easy and all that kind of stuff. And I like to say everything is easy until you want to do it well. Programming is difficult. And because it's so difficult, we have to manage complexity. All right, so one of the things. And because programming is hard, building software is even harder. There's a lot more that goes into building software than writing a for loop and writing an if statement. It takes a little bit more. For one, we have stakeholders. Stakeholders always want you to deliver something faster than you probably can reasonably do it. They want it done tomorrow, but in your mind, you're like, man, you know, this is going to take 2 weeks. But they're like, all right, well, we'll give you 2 days. Well, now we add complexity because now we're trying to do things fast. So we're going to take some shortcuts which can come back and bite us in the ass in the future. We have our product owners. These are the people who should be writing the specs. And whether or not they do that is another story. But because we have these people who are saying what this product should do and they're always changing what should be done in the product, well, I mean, that makes our jobs a little bit harder as software developers to meet their needs. We also have developers, and I imagine many of you probably fit into this camp. How many of you have used a product because it was the cool thing, the new thing? No one? No one's honest? You all are lying to me. I don't feel bad for any of you anymore. All right, I have 3 or 4 honest people. Okay, all right. Developers have their own wants and needs. They always want to use the coolest, the latest, the greatest, all of that kind of jazz. They always want to use the latest and greatest technology. And because of that, we have to balance developer wants and needs with the actual business needs, right? Like we can all make a case that, hey, we should be using this because it's 10 times faster. But what we don't say is that, yeah, it's 10 times faster, but it doesn't scale when you start to add in additional developers onto the team. We have QA. They come on and basically shit on your product and just say, hey, everything you did is wrong. And they send it back to you. And as a developer, you're either one or two people. You're the one that's like, okay, I'll go and fix it, or you'll push it back up to the product owner and say, hey, this is your fault. Like, your specs weren't written well. We did exactly what you told us to do. And finally, you have your users, and users they're going to do what users are going to do. They're going to make sure that your software is used in ways that you never would have thought possible. They're going to do things that you're like, why would any sane person do this? Well, guess what? As part of building software, we had to account for all of this. And I want you to notice that all of these different actors, they have something in common. They're all humans. They're all people. And whenever you have a lot of people involved, you have communication. So I like to say that a lot of this boils down to communication. And we'll get into a little bit about that later. Oh, here we go. So this is a German guy. He's probably one of the forefathers of organizational management and all that kind of stuff. And he has this to say: the most important thing in communication is to hear what isn't being said. There's these things called assumptions that we all tend to make. And sometimes we don't share those assumptions with others. And when we don't share those assumptions with others, we end up in peculiar places. We end up with software that doesn't actually meet the needs because we assumed that the user would do something a certain way, and it turns out that that assumption was incorrect. But had we said that, perhaps we could have avoided something. And I like to point at this because what if you can codify the things that aren't being said? Like, what if you can put guardrails in your application so that you don't have to say the quiet parts out loud? You could just be like, you know what? You do you. Just know that the program won't compile unless you do it the way that it's supposed to be done. Anyone here disagree with the statement? Remain sitting if you disagree with this statement. Okay. All right, so you in the black shirt, why do you disagree with this statement?
Didn't want my colleague here with a laptop. I actually agree with this.
Okay, all right, okay. I just wanted to pick on you. I'm just messing with you. So the only constant is change. And we should know this fundamentally. I think this is the core design principle that we should have in all of our software. We should design it in such a way where it's adaptable to change. Because at the end of the day, that's the one thing that's constant, is that it's going to change. I learned this the hard way, actually. When I built the system, I was like, oh my gosh, this is perfect. It does all these things. And then like 2 weeks later, they're like, yeah, we needed to do A, B, and C. And I'm like, okay. And I go back to my little dark corner and I build a new thing. And then I'm all happy about it. I present it. I'm like, all right, it does this and this. And they're like, yeah, but we needed to also be able to print to a printer. And I'm just like, okay, I didn't think about that. And turns out that we can't think about everything. So if we could design our software in such a way where it can be amenable to change, where we don't have to go and change all of our core business stuff, it'll make our lives a little bit easier. And we'll get into that. So how can we avoid it? Unfortunately, we can't avoid change. It's just something we're going to have to deal with. But there is a way that we can deal with it. I imagine that most of you are familiar with object-oriented programming. There is a tenet in there called encapsulation. Right? So we can actually take that. For what it's worth, this talk isn't really about any form of programming. Like, in fact, I'm more of a functional kind of person. But I like to borrow techniques from different paradigms because they all are useful in certain contexts. So we're going to use encapsulation to kind of shield ourselves from things that may change that we don't have any control over. Who here can give me a good definition of what encapsulation is? volunteers, just say it. Otherwise, I'll give you my definition, and it'll be wrong on purpose. You. You gave me eye contact, bro. I mean, shit. Everyone else was looking away like this. You gave me eye contact.
I should have picked that up from school, but I avoided the teacher.
I mean, hey, you did it for 2 or 3 seconds. I mean, we had a connection, and I'm just like, all right, you must want to say it.
No, I think encapsulation is really trying to come up with a model that encompasses all of the design traits for it, like coming up with an entity like customer owners or whatever. All of the business constraint is within the same implementation.
I would say so. That's one aspect. I have another hand. You're volunteering, so go ahead and pick you.
Would be actually protecting the business logic. So you just provide means of exposing something that you really want to be exposed.
Okay.
Let's say to a structure where everything is found.
Okay, so exposing the things that you want to expose, like you're hiding information. Kind of like, I think you're like hiding business logic details. It's just hiding information. It's important to hide information because if you make something publicly available, someone will use it. Remember, like, I'm not going to go back to the slide, but users can also be us. It's not just the end user. Sometimes we're the user of our own libraries, and it turns out if you give the man the opportunity to push a red button, and you tell them, hey, you know what, don't push this red button, they're probably going to push that red button eventually. So here's the answer: discipline. This is how we can prevent all of our problems. It's discipline. Of course, it's easier said than done, right? Like, no, just don't do the thing. Just don't push the red button. Everything will be fine. Turns out this is life. Things don't work that way. So, how can we, there we go. Yes. Sorry, I am lost in my slides now. All right. We don't want to let irrelevant details make our life harder, right? So that's one of the things we're going to keep in mind when we're thinking about discipline. Like, whatever we do, we need to make sure that we don't let irrelevant things make our life harder. Here are the details that I'm referring to: your database, third-party APIs, GUI frameworks, your web framework, your user interface. And I don't mean just a graphical user interface. I mean any user interface, whether that be a CLI, a web API, an Excel spreadsheet, a Wacom tablet. It doesn't matter. Like, we want to make sure that we don't let our software be affected by our UI, as well as our infrastructure. All right, so when I said discipline, I was just being cheeky. In reality, we do it by architecture. And as you see, architecture is the fundamental structures of a software system, and the discipline of creating such structures and systems. Discipline is at the core of this. We have to maintain the discipline, otherwise we get into situations where we start off with a pretty decent system, and we continue to just pile on stuff, and eventually we end up with a mess, right? So there's this guy, I think his name is Martin Fowler, Uncle Bob. Y'all heard of him? Uncle Bob Martin or something like that? Where he's like, architecture is the stuff that matters, whatever that is. This is, I think, it's another definition. It's not as poignant as his, but like, here's another one. It's about making the fundamental structural choices that are costly to change once they're implemented. And this costly to change, this may seem like something that you may not want, but I'm going to argue that you actually do want something like this, because this is how you put in guardrails, right? Like, this is how you prevent people from doing things that maybe they shouldn't be doing. And when I say people, keep in mind that you're a different person every day, so people includes yourself, right? Like, I have messed up my own projects, and yeah, I sometimes wish that I would have put in some guardrails for myself. Architecture is also design, but not all design is architectural. Right? Like, just because you design something doesn't mean that it's architecture. And I'll try to make that a little clearer in these two examples that I'm going to show you, like actual code examples, at the end of this. And I'll actually try to get through the slides fairly quickly. We're going to go over a few architectural patterns, and this is where I'm going to ask for more participation from you all, because I'm just curious to know like what you all have to say about this. So here's one of them. Event-driven architecture. The style of architecture that focuses on the creation and reaction of events or changes of state. I'm curious, how many of you all have had experience with event-driven architecture? What type of project, in the blue shirt, what type of project were you working on? React. Oh, okay, you stole my thunder. Okay. All right. All right. Anyone else? No one else is done? All right. How about you?
It was just a web app that had a couple different things that had events that triggered.
Y'all are both stealing my thunder.
Behind the scenes.
Y'all, all right. How about you?
Kafka message passing system.
Kafka message passing. Okay. All right. So the only times I've ever had experience with event-driven architecture is when I've done stuff with the DOM, the web, as well as sensor data. When I used to do stuff, there's something called cathodic protection that you do on structures out in the ocean to make sure that they don't corrode too fast. You want to be able to respond to something when something significant happens. And turns out, if you don't know all of the things that can happen, event-driven architecture can be a little bit of a challenge because you have to know what your events are. That's one of the issues. So let's talk a little bit more about this. This makes integrating with third-party services a lot easier because now you can kind of abstract away from like the actual service, and you could just say, hey, whenever this event happens, do something. If you've used webhooks, chances are you've experienced something along the lines of this. This is a way that you can create a loosely coupled system, right? Where you're not really depending on the system itself, you're just dependent on an event that occurs and you want to react to it. It also removes temporal coupling. This is incredibly important because a lot of times in the real world, we are interacting with a lot of different systems and not all systems are performant. Some systems, like if you're doing stuff with the banks, it may take a day or two. Chances are you don't want your request sitting on your user's browser for a day or two. You would prefer to have it just do the thing. You send an event to some other process or service, and it goes off and it does some work. And then maybe when it's done at some later point, maybe a day or two later, we send another event, and then some other software can go and respond to it. Maybe send an email, maybe send a text message, that kind of thing. The other really cool thing that you get for free, I think, with event-driven architecture is fault tolerance. They're a little bit more resilient to failure because if an event like fails to get sent or if it's failed to get received, you just send it again, right? And like that code behind can just go back and reprocess it. There are some cons to this though, and the number one is that there is no clear process to the ordering of things. And I imagine that if any of you have done web development, you understand this very deeply. Like we have this thing called asynchronous code, and sometimes it doesn't behave the way that we expect. And because there is no clear process order, it makes our error handling a lot more challenging. We can't simply debug because sometimes the event that's sent had all these other preconditions that must be met that we may not be able to meet ourselves. So like it makes our lives a little bit more challenging. Here is a diagram of what event-driven architecture may look like. So if you can imagine, we have a transaction that's made, and chances are we have an order that was placed that resulted in that transaction. And as a result of that order, we want to create a shipping label, and at some point, we also want to actually ship the item. And when we ship the item, we may want to alert the user, the customer who bought the thing, hey, here's your tracking code. And if the item gets to a certain destination, we may want to alert them and say, hey, your package is at this place. We're able to do that with event-driven architecture, quite simply, actually. In fact, I think it's one of the more logical choices if you're building a system like that. To the people who stole my thunder, some of the main things that employ this is the DOM. Who here has used jQuery? Y'all remember that? Who here likes jQuery? Just curious.
I liked it when it first came out.
I liked it too. It made life a lot easier when it first came out. Yeah. Yeah. And the other one is webhooks, which I already talked about. So we'll move on to another style of architecture, but this one's going to be presentational. This one right here is not really a presentational architecture. It's more of a just like, I would call it more of a logical, like a process-driven architecture. Here we have MVC. I imagine that a lot of you are very familiar with MVC, the Model View Controller. It's used to implement UIs, but I want to key in on this word UIs. It doesn't just mean web, which I feel like that's what it's been kind of conflated to mean for a long time. It could be any type of UI. Yeah, so its main tenet is just like separation of concerns. You have a model and your controller and your view, and you try to maintain the separation of what is responsible for what, right? And if you think about it, it makes it less likely that if something changes, you have to change everything else. Except unfortunately, the way that MVC is often implemented is if you change something, you also have to change everything else, right? So it's unfortunate. So we'll get into what the model is. A model, it's the thing that manages all of your business logic. That's your data. If you have, who here is familiar with a repository pattern or active record or any of these types of things? Anybody familiar with that kind of stuff? Models? So you all kind of have you all are familiar with models. Views are the things that are going to handle the layout and the display. Doesn't just mean on the web. The display could be your CLI. I'm going to keep iterating on that point. And your controller is going to route all of your commands to your models, and it's also going to route all of the changes in your models to your view, so that whenever you make a change, your view changes. Who here is a fan of MVC, just out of curiosity? Like, who loves MVC? You love MVC, you love MVC, okay. Who here hates MVC? Everyone else? Who here is just like, I don't care about MVC? I should see most of your hands up because you have to respond to something. All right. All right, here's a little diagram of MVC. I do want to say that even though we have these lines, oh, that's right. Even though we have those lines there, this is the idealized model. In practice, you may not get this, but we're going to pretend like this is, like this is the theory world that we're in right now. And we have our model, which you see, we define our data structures. And this is also where we're going to put all of our updates, our persistence, we're going to put that in our model. Our controller is going to be all the things that has our business logic. So if something happens on the view, we want to say, hey, model, someone just created a new post. Go to the post model, add a new post, and it lives there. The model is responsible for all the persistence and all that kind of stuff. And then we have our view. And the view is what the user often interacts with. So the view is going to have two-way communication with the controller, right? So if something happens on the view, we want to say, hey, controller, this happened, so the controller can go back to the model and let it know. And in some cases, and I mean, this line right here is actually the one reason why I'm not a big fan of MVC. Flux does things a little bit differently. You don't talk directly to your view, you talk to something else, and then your view will update based on that. In any case, some of the tools and technologies that use MVC are Ruby on Rails, Ember, Cocoa for iOS, Mac OS. So MVC is actually quite prevalent. And given that it's used in like the majority of software that I've seen tells me that it must work for a lot of things. Although, a lot of the issues that I've had where I've had to change certain things about my application code, they were in these style of architecture. So you still have to worry about it. Hopefully the one that we talk about, it will alleviate that entirely. So here's one that's really interesting. This is MVVM. I get the feeling that a lot of people here are familiar with Microsoft technologies. Who here has done WPF or Xamarin development? Okay. You. How do you like Xamarin or WPF? Which one are you using first? Xamarin. How do you like that? Like, do you? Honestly, I feel like that's the only con, is that it is an adjustment. But once you make that adjustment, how is it?
No, yeah, then it's super easy to kind of get around and you understand where everything is. It's just a different way of thinking when you first try it out.
Yeah, I 100% agree. So, model view model is very similar to MVC with some minor nuances, but we'll get into that. So let's first go with model. I'm going to read from my notes here. So the model is your application's stored data. This data represents objects and operations in your business domain, and is independent of any UI. Right? So like, in this case, a model is going to be a little bit lighter weight than a model in MVC. The model in MVC is going to have operations that you can take on the data, such as insert, delete, update, that kind of thing. Here's where things get a little more interesting. The view model. This is a pure code representation of whatever is in your UI. All right, so here's an example. If you're implementing a list editor, your view model will be an object holding a list of items and exposing methods to add and remove items. All right, so that's the main difference, is that your view model is going to encapsulate all of the logic for updating all of your state. So you can think of it as state if you're like a React land like I am these days. Your view is very similar to the view in MVC. It's just the UI, right? But things get a little bit more interesting here because we need a way to update our UI. And this is where we employ something called data binding. It's often the case that we employ two-way data binding in MVVM. If you've ever used Angular or Knockout.js or Xamarin or any other tool, you're using data binding. And it's actually quite nice because it's more of declarative. I find that with MVC, it's more imperative. You have to say, oh, do this thing and explain how to do it, whereas with data binding, it's just like, hey, bind it to this thing. And whenever it changes, it just changes. You don't have to really think about it, which I like a lot. One of the main advantages of MVVM over something like MVC is that it's a little bit more testable, at least the things that matter, right? Because you have a pure code representation of your UI, you can write UI tests without actually looking at the UI, which is quite interesting. Because remember, everything that's in your UI is in the code. So if you just test that, then you have a very good idea of what your UI is going to do once you actually hydrate it. It also facilitates easier parallel development. Why? Well, it's because we're using data binding. We just agree on these contracts here. We just say, hey, we're going to give you these properties and it's going to do these things, and someone can go off and design the UI and you can go off and design the view model, and like magic, we get together and it should just work. That was my experience, at least. I don't know, I can't say. How was your experience? Was it pretty decent in that way? Okay. So you didn't really do the design or anything? Like, okay, yeah, I don't I didn't either. But here's the con, and we've already touched on it. It can be very difficult to use. It takes a shift. It takes a shift. It's like a leap of faith. You just have to trust it, and eventually, hopefully, you'll get it. It can also be overkill for smaller projects. Like for real. It's a lot of moving pieces. So I only recommend this for larger projects. Here is a diagram of MVVM. As you see, it looks very similar to our MVC, except our view model is at the center of everything. Those arrows are our data bindings, and the way that we update our views and our view models is via commands. All right, so now this command is what I want you to really think about. That command is really just an API, it's an interface. It's explaining how we can use this view model and how this view model is going to use other things. And this is actually a way that we can create a loosely coupled system. All right, so here's where we're getting close to the demo. All right, so hexagonal, ports and adapters. How many of you have heard of this one? All right, curious. Have you ever employed hexagonal architecture? What was your experience of it?
It's nice for shipping.
Yeah, unfortunately, it seems like the more further down we get, they get a little bit nicer, but they do take a little bit more effort or discipline, as I like to say. To take a little bit more discipline, but if you employ it, it makes your life a lot easier. How about you? Did you use a specific variant of hexagonal, or did you use explicitly hexagonal?
I haven't used it, read about it.
Oh, you read about it. All right, so what are your thoughts on it? What are your opinions so far?
I like what I read.
You like what you read? Okay, so I hope that you'll like what you hear. We'll go into it. All right. Just let you take it in for a little bit. I'll walk you through it in a second. All right. I'm going to try to briefly describe this. I'm going to sound about. All right. Oh shit, I don't have much time. Okay. I will go through this quickly. Here is what our user interacts with. Right? We call these our driving adapters. Over here is what our details are. All of our details, like we don't really care about that. Everything in here are the things that matter to us, right? So the idea is that if you segregate all of your stuff, all of your details onto the edges of your system, these all can change, and this doesn't have to care. That's the short of it. And because I'm running out of time, I'm gonna move fast now. Apologies. All right. So we're going to go through a few things. So this is independent of your framework. The architecture does not depend on an existence of some library, right? It allows you to use whatever framework you want, like any framework you want, whether it's like a mobile framework, a web framework, cloud, it doesn't really matter. It produces testable code. It's one of the main benefits is that because all of your core logic is here, this is really all you have to test, right? The things that matter to you. I don't think that other stuff is that important, so let's go through. All right, so how do we get there? Well, we employ design principles, right? So remember, architecture, design, they kind of go hand in hand. So we have some principles that we want to go through. The first one is going to be dry. And who here wants to tell me what dry is?
Don't repeat yourself.
What?
Don't repeat yourself.
What? All right, what about the second one? All right, keep it simple, stupid. What about Yagni? You ain't gonna need it. Mm-hmm. I do want to, I have this graphic here to kind of explain the difference because they are kind of similar, Yagni and KISS. Yagni is all of these little fun shapes over here. Oh, we need the little triangle thing, star, we need this, and you ain't gonna need it. It's just like, you know what, we don't need it. Let's get rid of them. Keep it simple, stupid. It's like, instead of having these weird shapes, we just need a square and a circle and some colors, right? So that's the main thing. And we also are going to employ something called solid design principles. I imagine some of you are very familiar with this, but I am going to go through it right quick. But before we move on to that, I do want to say that the reason why we have these design principles is to control our complexity, right? Like we have two different types of complexity. We have essential complexity. Remember, I was saying that software is inherently difficult. Like some of it is just going to be complexity that is just there because we are trying to do something hard. We're trying to solve a problem that's hard. But we also have accidental complexity, and that's the thing that we try to limit when we use these right here. So accidental complexity is any issues developers have to address on their own way to solve essential problems, such as cache management, optimizations, other stuff like that. All right, solid design principles. Single responsibility principle. Does this sound familiar to anyone? Are we all in agreement that solid is pretty solid? It's pretty good stuff? Yeah, we are? Well, I didn't hear everyone, so we'll go through it. Okay, so single responsibility principle states that a class should have only one reason to change. All right, so these are for object-oriented things, but like, let's just pretend that we can use this anyway. Open-close principle. Objects should be open for extension. Or is it? Oh, yes. Yes, open to extension, but closed for modification. Sorry if I get this wrong. I don't actually use object-oriented programming languages. And I actually have a little slide here where I map it back to FP for me. All right, the Liskov substitution principle, which is a subclass or subtype of some entity, should be replaceable for its higher level type. So if you have something like a person, and like a person could be a female or a male, you should be able to use a male or a female in anything that uses a person. Does that make sense? Because they're all the same thing, they derive from the same thing, okay? Interface segregation principle. This basically states that you should program against an interface that you control. That simple. And then the final one, and this is actually the whole part, this is literally the premise of this talk, is we want to be able to invert our dependencies. That's it. Another way of saying that is your entities need to depend on abstractions, not on concretions. Or another way is use an interface. That's another way of saying that. So this is my hot take. Solid principle makes object-oriented programming usable. but you get all this for free in functional programming. So here's how they map. Single responsibility principle, we have functions. Open close principle, well, we have function composition and higher order functions. List scope substitution, we have generics. I think most type systems and most object-oriented languages have generics as well, but we have them too in our functional languages. Interface segregation principle, well, we have types, contracts, protocols, interfaces, that kind of thing. And dependency inversion principle, function parameters, just pass an argument. That's it. All right, so you're probably like, all right, I came to this talk, you lied to me, you said we were gonna be talking about web, and all right, I'll give you what you came for. We're gonna talk a little bit about web. So here's how you solve it. Dependency inversion principle. It's very simple. And like I said, it's so simple that I actually had to make my demo even more complicated, and also I'm gonna show you a more advanced use case of this. But yeah, let's go over the simple example right quick. All right, maybe it's not that simple to get it over there. That's not what I wanted to do. I'm gonna have to look because it's really hard to do this. Not that smart like that. All right. Can you all see this? Should I zoom in? All right. Here is an API endpoint. This is a Next project, by the way, Next.js. It's just a simple Next project. And the one thing that I want to say is this is my web framework. So for all of this, just assume that this is my web framework, right? Like we're going to get a request, and we see here that it's typed as a Next API request and all that kind of thing. All right, let's actually look and see what we're doing. This is very simple, but you can imagine, just use your imagination, that we could do a lot more stuff in this particular function. This function is going to parse out some data from a query, right? That's really all it's going to do. It's also going to parse out a body. In that body, we're going to have a quote. Right? This is, you know what? How about this? Instead of me just jumping right into it, let me just show it to you. I can actually do that. This actually works. Okay? So this is me proving that it does something. So this is what it does, right? So it's just a thing where it's like it'll give you a random quote, and you can send it to your subscribers, and we use OneSignal to send it to your subscribers, right? So you can send it to your daily, your weekly, your monthly subscribers, right? So if you think about it from just this UI perspective, we're going to, if we click this, this will add something to a query parameter, and whenever we send this, it's going to send it, and whatever's in here, it's going to be sent to the server, and it's going to do some stuff. That's really all this is doing. All right, so here's how we're doing that. We're having to parse our HTTP requests, all right? Well, we also have to create this client, a OneSignal client, in this function. Already, we're breaking our single responsibility principle, already. But let's just pretend that we're not disciplining right now. We're just gonna keep going forward. We're also doing some switching, right? Like we're trying to say, all right, well, depending on what type of event we've gotten, what do we wanna do? How do we wanna handle it? So we're doing some stuff here, and we're gonna send something. We're gonna send a notification. What you'll notice is that we're blocking. We can actually employ event-driven architecture here. But for right now, we're just gonna block. And then this is where you can imagine that we're doing a little bit more stuff. Like we have a database, we have caching, we have logging, just more business logic. So just looking at this function is doing a lot of stuff. If we decided, hey, you know what, Next isn't working, and I want to use Remix, I had to change a lot of stuff. A lot of the stuff that I'm changing doesn't really have anything to do with my app, but I'm having to change my app because I'm taking a hard dependency on Next. Oh, sorry. There's a simple way to get around this. Here is the same functionality. I'm doing my parsing. Now, I encapsulated my actual business logic into this function. And now I call the function. So now if I decide, hey, you know what, I don't want to use Next, and I want to use remix, well, I can literally just say, all right, well, let me just rip this out, because at the end of the day, I'm just doing a function call, right? Like, my dependency is inverted at this point. This is the simplest use case, right? And this is why I was like, all right, I need to make it a little bit more complicated, because like y'all will be like, oh, it can't be that easy, and it really is, but like, you know, some people only will do something if it seems more complicated. So I'm going to do a more complicated example. By the way, let me show you how this is organized. I've actually separated out my business logic into a little folder here called app. And my random quote stuff is here. So if I want to change stuff, I can do it here. Unfortunately, I'm not going to have enough time to do the little exercise that I wanted to do, which is actually walk you through how we can do it with this as well, where like we can pass this in as a function, thereby inverting our dependency again, so that we don't have to take a hard dependency on our OneSignal API. Maybe we want to use some other tool to send a notification. Our business logic shouldn't have to care how a notification is being sent. Right now it does, really. So I want you to just key in here is that this right here is an example of a hard dependency. This is tight coupling, and we can do better. And maybe, I don't know, maybe, I'm curious, do y'all want to see the challenging example, or do y'all want to just walk through this? Because I could do one or the other.
Challenge.
He said it, so we'll do it. Oh man, good luck. Okay, all right. Here's an application. Doesn't matter what this application does. Just know that this is the entire application, and what you do not see is anything that even references a web server. These are all my things. Anything that has an at, these are like paths that I've defined myself that is calling code that I've written myself that doesn't take any hard dependency on anything but my interfaces. And you'll notice that there is absolutely nothing to do except for that. Ignore that. I've got to refactor. Ignore that. There's nothing. There's nothing here that is calling anything that if it changes, I'm going to have to change this. In fact, I've already ported this to another web server that's completely different. This is an Express app, by the way. And I've ported this into Next.js, and I'm now using Cloud Functions. All right, so this is, yeah. Let's go to my server. You'll see here that in my server, I'm actually setting up a GraphQL server. And I also have an HTTP server. And what you'll also notice is that I only do this. This is the entry point into my app, this base router. That's it. Let's go into this base router. Oh, look at this. All right. Oh, we have all these other routers. Let's just look at one of these routers, because there's some magic here that's happening. Remember that other file that we were just in that just had all that bootstrap code, all that stuff where it's just like you don't see anything except the Axios that I told you to ignore? Well, I'm actually just calling my controller.token. That's a function. I'm using something called currying to like remember some of the dependencies that I've injected so that I can set it up and configure it just the way that I want and use it here. And notice that all I'm doing is calling another function and passing this function into that function. Here's the higher order function right here. Well, what is this doing? All right, well, this is the magic. This is an example of an adapter, right? So this is something that's going to take something from the outside world and change it into something that my application cares about. My application doesn't care about HTTP. It doesn't care about GraphQL. It only cares about the data model that I've set up. So this is what I'm doing that translation here with. So you'll see here that I am taking a request. This is an express request. And I'm doing some things with it. And you'll also note here that I define my own interface for HTTP requests because I only care about certain things, right? So I do that. And then I have this handler here. This is where things get a little interesting because this handler, if we'll just come back up here. This handler is passed in. This is like an example of me passing in a callback function, remembering that state because in TypeScript we have lexical scope. So I can set it up and configure it just the way that I want it so that whenever I call this function, I just bind it to the function that I wanted to run. I know that sounds confusing, so I will go back to here. Here's the function that I want to run. I'm binding this function to this route so that whenever this is called, it's going to run this function and it's already going to, it's going to parse the request and set it up in just the way that I like it for my controller to then handle. We'll go into a controller momentarily. But yeah, from there, we're just going to call our .then, which is just, effectively, this is a wait. We're just going to make sure that something happens, and if something happens, we're going to process the response and send it back. So this is the thing that's actually doing all of the interop between the web server and my app. But there's also another thing that I have to have in place, which is, remember, I said that my app doesn't know about HTTP at all. So I need to figure out some way to get from HTTP land to my app land. That's what my controller does. We'll go into one of those right now. And you'll see that here, I'm actually using like the same thing. I'm passing in a function, and then I'm building another function that I then use somewhere else, right? Y'all, he said that he wanted the example, the hard one, All right, so let's jump into this one. All right, so here is a generic function where I pass in something that I call a workflow. A workflow, in my case, is my business logic, my app, the things that I don't want to ever change. I pass that in, and then I'm going to return another function, right? So like, I have a function, I call it, I give it a function, and it's going to spit back out another function that I can then use. And in this function, I actually have a few like lifecycle functions that I've developed. One to actually make sure that to validate the HTTP request, to make sure that it actually has the things on it that I expect for this specific workflow. It has something that's going to sanitize that request because you should never trust user input. Hopefully, I mean maybe you do. It's also going to have something that's going to map my request. I don't know if it has it. If I have that here, maybe I do. Oh, I do. Yes. It also has something that's going to map a request from HTTP land to my app land. And then, thank God for Command Z. All right. And then I have this other function here, this on workflow response, which is what is going to happen once my workflow is finished processing. Because remember, I have to convert whatever result comes out of my workflow back into HTTP land because HTTP wants HTTP. So this is how I process that. Now you may be wondering, all right, well, hey, like you pass in this function, but like, how is it actually calling the things and doing the things? And it just goes deeper, which is, I did ask if y'all wanted me to just do the, it goes deeper. And you'll see here, we're making use of generics, those things that I kind of hinted at. We're making use of some generics. And we see here that, you pass it a workflow, and you give it this config object, which has our lifecycle methods. And you'll see here that I am defining a new function, a new function. This is my controller. That's going to take in the HTTP request, and it's going to call these lifecycle functions on it to actually process it in such a way where I can call my workflow. And we'll go into that. So you'll see here, we have our workflow request, and we're just calling our on-map workflow request and passing the workflow request. I'm sorry, the HTTP request, and we get back out a workflow request. We're going to sanitize it. All I'm doing is calling that function. And then as a result, I am going to call the passed-in workflow. And that's going to give me back a result. That result is if we're looking at lands, that's in my app land. We want to get this back into HTTP land. So in order to do that, we call this on workflow response, that last function that we looked at. And this is the thing that's going to convert it to something that's HTTP so that when I get it back into my controller, oops, all right. All right. I'm actually out of time. I apologize. But yes, once we're out of our workflow land, we go back to our HTTP land. And from here, our make express handler is going to pick it back up and then send it back out to our HTTP server. Now you may be thinking, oh, that's a lot of work and all that. Yeah, it was. But as I said, I was able to change my server and not have to do anything. In fact, I have tests for all of these things. Oops, wrong one. So I don't know if y'all are, some of you Who here likes writing tests? Y'all, no one? Well, here are my main workflows that I have in this particular one that I can show. And you'll see here that I've tested, I have tests for the things that matter. I can test my entire application irrespective of my UI, right? Like you saw that I have an HTTP server, I also have a GraphQL server. I'm serving them from the same app. So at the end of the day, like I'm actually doing that. And this goes deeper than just my HTTP server. Remember, I said that no, the web was just me to get you in here, but I'm doing that with my database as well. So if I change my database, which I have, by the way, my core application code doesn't care. I'm able to change it, move on, and make sure that my stuff continues to work. And I would run these tests, but I'm actually afraid that it's going to fail now because y'all are looking. So I can actually run these tests, and everything will continue to work just as they had before. And that's all because I just employed a little bit of discipline to make sure that I put things in certain places and made sure that I didn't take hard dependencies. So this is what a loosely coupled system looks like. It looks a little challenging, but I promise you, once you get used to it, once it clicks, it's hard to go back. Because this is a system that's amenable to change, right? Like, it doesn't matter what happens because at the end of the day, I'm relying only on my interfaces, right? All right. So, oops. I hope I didn't close my presentation. All right. So here are the takeaways that I want you to leave with. I'm not going to full screen it. Change is inevitable, so design for it. You should always prefer loose couplings to tightly coupled systems. Always keep your concerns separate. Rely on abstractions over concretions. Another way of saying that is rely on interfaces. Always program to interfaces. Keep your implementation details at the edge of your system. And this way, whenever you need to change those things, which are going to change more than likely, your actual core code doesn't have to change. And the last one is use solid principles as your load star. Like whenever you're thinking about something, like keep that in the back of your mind and say, all right, well, is this solid? And if it is, then keep it and move on. That's it. So thank you all.